किसी क्रिया के जो कणुओं के पास होने पर, जो क्रियाकारक कणुओं के पास होने पर क्रियाकारक कणुओं के होने पर परिवर्तित क्रियाकारक कणु उत्पादों में परिवर्तित दहली ऊर्जा कहलाती है। सब क्रिया की दहली ऊर्जा उस सब क्रिया नोट कीजिए, यह इसका मतलब अलग अलग अभिक्रियाओं के लिए ऊर्जा किसी होती है।
Oh, okay. Now just see, am I audible? Am I audible? I want to see green signal in the chat section, kids. Do let me know. Am I audible? Hey everyone, very good evening. Vanakkam. Just show me the green signal. Can you hear me? Why no one is yeah, yes. Now I can see green hearts. That's really fantastic. Now I can see that everyone can hear me, can see me. Yes, kids. This biomolecules. This chapter is not only important in biology, it holds a whole lot of weightage for chemistry. Means 2 chapters if you are preparing for NEET, and those who are preparing for IIT, IIT JEE and advanced kids, most of the students, they are always having in their brain that we won't be able to solve this question which is based on biomolecule. My dear students, let me tell you, I will teach in such a way that each and everything related to this biomolecule chapter will be cleared. You will feel, really you will say, sir, now it's looking easy peasy lemon squeezy. At the last you will say done and dusted, and this chapter will not take too much time. Maximum of 3 to 3.5 hours it will take. So it will get completed almost near about 9 kids. Now this is my duty, this is your Baba HSP's duty, that I will make you 100% confident in this chapter. What I will teach in this chapter, let me first tell you. I will deal with biomolecules chapter. In this chapter, I will tell you glucose first. Once you are able to understand, not only understand, once the glucose structure goes in your hippocampus, then everything will become super easy. Starch, amylose, amylopectin, cellulose, each and everything you will say, wow, sir. Not only the structure based as well as reactions also, you will be able to understand. Then fructose you will be able to understand, and then I will tell you all the molecules based on these. Then amino acid, vitamins, DNA, RNA. You will say, oh sir, I don't know biomolecules. No, my dear students, whatever you know, that is not 100% which is required for your examination. You will get 100% from Baba HSP only. You have to give your time. I will give you knowledge, and not only the knowledge, I will fix that thing in your brain. That's my promise. This is your Baba HSP's promise to you kids. Now, Who is Baba HSP? I will show you who is Baba HSP. But before that, I want to see some fire in the chat section so that I can understand everyone is present. You have to mark your attendance in the form of hit the like button. Everyone smash the like button. That's your attendance. Let me check it out in the chat section that everyone is here. All my dear HSP and army is there. All dear HSP and are there. Sahana, welcome. Medico, welcome. Deepak Kumar, wow. Sahana, thank you. Ansha, Vanziga, our God, oh my God. Shruti, Jyoti, fantastic, wow. Reaction with cricket, Deepak Kumar, fantastic, fantastic. Now let me start. Before starting, let me show you something. These slides. First of all, hit the like button, everyone. Hit the like button. Hey, yeah, this is your Baba HSP. Hit the like button, everyone. Now, unlock the champion in you. Unlock the champion in you. Flat 50% off on all NEET UG subscriptions up to 1 month free extension. Offer ends tomorrow. Kids, use code HSP10. What is the code, kids? HSP10. This is the code. Then you will get huge discount each and everything along with Baba HSP's mentorship. Now, this is the team you know very well. Your Ambika ma'am, the best in bio in the whole world. Queen of bio. Wasim sir, you know very well, the best for chemistry, and Yava sir, our lovely Vayava sir for physics. And this is your Baba HSP simple teacher, right? So, this is available, this Avengers batch, Team Avengers, the chance to study with the world's best team for English, teaching English. And this course is available just for rupees 5499. For this, you have to use the code. Once again, let me tell you, HSP10. You know very well, this is the best team, kids. Now, once again, I would like to say the same team is available for Nimbus batch. If I talk about Nimbus batch, that is class 11th. Once again, it is available for just rupees 5499 if you apply code HSP10. HSP10 is the code. You can help others, your friends, your colleagues, your classmates, your relatives, everyone. You can pass the information. Sharing is caring, and if you are helping others, Almighty God is going to help you a lot. Now, let's start with glucose. I will start with glucose. If you are ready, I want to see fire along with green signal in the chat section. Let me check it out. Let me check it out. Green signal in the chat. Green signal in the chat. It's for chemistry, both for IIT, medical, every student can get benefited. Glucose. Now kids, you have to make a promise. You have to make a promise that whatever I am going to write, I will not use any printed slide. I will move a little bit slow so that you can make the memory of this chapter in your hippocampus for always. So you have to make a promise. Whatever I am writing on the board, you will write in your copy and then try to keep it in your brain so that whenever I am going to ask, you can answer it. You can reflect it back. That promise I want from your side. And for that promise, you have to show me fire in the chat section that yes, you are agreed. Those who can't do that, those who want to move very speedily, they can leave the lecture. Baba HSP never teaches for views. I am teaching here to make you perfect in this chapter. If you want to get, if you want to have the clear-cut knowledge of this chapter, then you have to follow whatever I'm going to tell you. If you are a good follower, then you can understand each and everything. If you're not a good follower, you can't understand anything. My dear students, I want to see your fire symbol in the chat section if you really want to get full marks, because the chapter holds a whole lot of weightage. Mera pyara bachcha log, kiddo cats, I want to see fire symbol in the chat section. So first, let me tell you glucose. Let me tell you glucose. What is being glucose, kids? Okay, just see. You know, glucose is a monosaccharide. What is glucose? Glucose is a monosaccharide. Am I right? Glucose is a monosaccharide. Agreed? Monosaccharide. It is sweet in taste. Sweet in taste. You know very well bio. This is the bio. You know sweet in taste. It is also known as aldohexose. 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 Am I right? Now, it is found in two forms, furanose and pyranose. Tell me, furanose and pyranose, these are the two forms. It is found in cyclic as well as acyclic structure. Now, this though you know very well. This much you know from the biology. So what I am going to tell you in chemistry? What's new, sir? Baba will tell you in chemistry the best thing. First, everyone remember the formula of glucose is C6H12O6. So this though we know very well. Okay, fine. Now second thing, what is required from your side? Everyone, you should know the Fisher projection. Fisher said, Fisher was the scientist. Fisher projection formula. What Fisher said? Kids, Fisher said that the topmost priority good should lie at the top. Most senior group should lie at the top. Senior most group at top, right? And the parent chain, number 1 I will give to this, number 2, number 3, number 4, number 5, number 6 should lie at the bottom, should lie at the bottom, should lie at the bottom. 1, 2, 3, 4, 5, 6. So this is the parent chain. Parent chain should go vertically downside. Parent chain should go vertically downside. This is the parent chain. PC, parent chain. Once the things are clear, I want every time green hearts. This point is clear. This slide is clear. Show me green hearts. Fast. Fast, fast. I want to see the green hearts. Once the things are clear, I want to see the green hearts. Each and everything, kids, say, yeah, everyone, say, yes, yes, how's the Josh, full on Josh, let me know, everyone, in the chat section that you are full on Josh. I will make you God. You are always saying that Baba is God of chemistry. Now from today, you will be the God of chemistry as well as biology. And if you're preparing for IIT, you will become the God of biomolecules. Your rank is waiting for you if you are with me. Remember that. So top group should be lie over here and bottom CH2OH. That's why always glucose is written like this. Have you ever seen glucose CHO at the bottom and CH2OH at the top side? No, never. CHO glucose is always will remain at the top. This is said by Fisher. We have to follow Fisher. Now, this much is clear. First slide is clear. Clear? Now, see the second slide. Everyone, see the second slide. Glucose. So I will draw this line. I will draw this line. I have drawn this line. Okay. Now, Vana, Randa, Monu, Nale. So what I will write? What I will write? CHO. CHO. This CHO is the mouth of glucose. Remember that CHO is the mouth of glucose. You have to follow what I'm writing. CHO is the mouth. You know, if I want to drink something, I will drink from here. Should I drink from here? Or should I drink like this? Or should I drink from my mouth? Everything which is going to react will react with mouth. Any chemical reagent will come that will attack on the mouth. This is the mouth. Why this is mouth? O negative, CH positive, and this carbon is sp2 hybridized. It is having two lobes. So consider this is the mouth of glucose. Now HOH, 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 CH2OH. Now, my dear friends, there is only one OH which is lying on the left hand side. All the OH, they are thinking themselves to be right, and that's why they are on right hand side. But the third carbon OH is on left hand side. Remember that the third carbon OH is on the left hand side. Is it clear? Focus on this third carbon, it is on left hand side. All others OH are on right hand side. And the last and second last carbon OH, last and second last carbon OH, they are on same side. Once the last and second last carbon OH are on same side, we will use letter capital D, not the small d, capital D. So that's why it is written as D because of this D. Let me write down here D, D, and whenever plus sign is written, that means in nature it is dextrorotatory. This plus sign is indicating dextrorotatory, and this on same side is indicating this D, and plus sign means dextrorotatory glucose, D glucose. Clear? Let me see in the chat section this much is clear to each and everyone. If yes, show me green hearts. Show me green hearts if this much is clear to all of you kids. Fast, do let me know if this is clear. Don't forget to show me green hearts, kids. Don't forget to show me green hearts. That's why this plus sign is indicating the nature it is dextrorotatory. So this is also known as dextrose. Dextrose. That means dextrorotatory glucose. Now kids, if this is clear, this is clear, this is clear. Now see what is going to happen. Just see what is going to happen. Now I will write the same glucose over here. I will write down the same glucose 1, 2, 3, 4 and 5. So CH double bond O, CHOH, CHOH. Consider that I'm your assistant. You are thinking and you are giving me the command, and I am your assistant. I am writing it. Just go like that, then only you can understand. CHOH, CHOH, CH2OH. Now this mouth is saying, I want to eat something. I want to eat something. So one thing you have to keep it in your brain, that most stable ring is 6-membered, then 5-membered, then 7-membered. In most of the cases, in 99% cases, 99% cases, this is the stability of ring. Stability of ring. That most stable ring is 6-membered, then 5-membered, then 7-membered. Now, this is saying that, hey oxygen, can you attack on me? So oxygen is saying, oh, I will attack from the right hand side. I will come in your life from the right hand side, as well as I will come in your life from the left hand side also, because you are being sp2 hybridized. So I will come from both the sides in your life and will form the bond. Because you are sp2 hybridized, you are having 2 lobes, pure p orbital, pure p orbital, pure p orbital, pure p orbital. So attack from both the sides, 50% attack from this side and 50% attack from this side. Now why only this oxygen is going to attack? See, 1, 2, 3, 4, 5, and this 6th is the oxygen. You will get 6-membered ring like this. You will get 6-membered ring like this. Just see. I will show you. This is known as pyran. Pyran. This is the structure of pyran. 5 carbon plus 1 oxygen. 5 carbons plus 1 oxygen. 6-membered ring. This is looking like 10. Let me write down 1 oxygen. 6-membered heterocyclic ring. Heterocyclic ring. I will draw the ring. First try to understand this is known as what? Pyran. And that's why you will get pyranose ring structure. This is going to form pyranose, looking like nose of pari. Pyranose ring structure. It is ready to form pyranose ring structure. Till now it is clear. I'm going to form the cyclic structure. First of all, do let me know till now it is clear what I'm going to write, what I want to teach you kids. Each and every point is clear to each and everyone. Just to let me know. Kids, your understanding is my first priority. That if you are able to understand, then only Baba is a good teacher. Otherwise, what's the use of Baba? Baba will not be having any use if you are not able to understand, kids. Dream TMC Madhu, very good Kumar. Everyone is getting it now. Let me tell you. Yes, somebody is asking, your notes are enough. My notes are more than enough. The things which are missing in NCERT, I will tell you those things also. My notes will include whole NCERT plus the missing part of NCERT. So if you are preparing for NEET, if you are a seeker for the first rank, or IIT, if you want to get full marks, my notes are more than enough. Now let's move. Let me draw first open chain structure, which I have told you. 1, 2, 3, 4. CHO, CHOH, 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 HOH, CH2OH. This is open chain structure. Open chain structure. Now kids, in aqueous medium, what is going to happen? See, in your aqueous medium, what will happen? 2 possibilities are there in your aqueous medium. Just see what are these 2 possibilities. 1 possibility, 2nd possibility, and try to understand what I am writing. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Now CH and this O was negative charge. This was positive charge. So this H plus of fifth carbon, 1, 2, 3, 4, 5. This is negative and this is positive. This H plus will go and attack over there. It will go and attack over there. And this O negative will go and attack on this carbon from this side as well as from this side. That means this CH, OH and CH, OH. Two possibilities are there. Can you see? If this is going to attack from this side, OH. If this is going to attack from this side, OH will come this side. This O and CHOH, because on oxygen H will come over there. This is carbon, this is sp2 hybridized. So the oxygen can form a bond with this oxygen. This oxygen can form a bond from this side. If this is going to form a bond from this side, this OH will go this side. If this is coming in the life of carbon from this side, then OH will be on that side. Two possibilities are there. And who is responsible for making this bond? The fifth carbon, oxygen, has come into the life of this carbon. Fifth carbon, oxygen, has come into the life of carbon. Here is only the difference. Here is only the difference, and this carbon has become anomeric, means chiral carbon. Earlier, this carbon was chiral, this carbon was chiral, this carbon was chiral, this carbon was chiral. This was attached to double bond, so it was not chiral, but this has also become chiral. One more chiral carbon got increased. Are you getting my point? Earlier, 1, 2, 3, 4 were chiral. 1, 2, 3, 4 were chiral. Only 4 chiral carbons in open chain structure. Chiral carbons number was 4. Now chiral carbons are 5. 5, and that's why the first carbon has become anomeric carbon. What will you say? Anomeric carbon, anomeric carbon, anomeric carbon. Rest of the things are same. Rest of the things you have to write down same. H, OH, H, OH, H, CH2, OH, H, OH, H, OH, H, OH. Oh, this will form over here bond. This bond has been formed wrong, kids. This bonding should be from here. So let me write down. It should be from here. Here. It's here, right? H, OH, H, CH2, OH. Now, I would like to say that this is your, now this is your what? This was D-glucose, this was D-glucose. Now remember, if first and third carbon OH are on opposite side, this is a game changer. First and third carbon OH are on opposite side, we will say alpha D positive glucose. And if first and third carbon OH are on same side, first and third carbon OH are on same side, we will say beta D glucose. Now they are going that side, they are coming back. This is a reversible equation. So all three, open chain, closed chain, closed chain. If I say this is X, this is Y, this is Z, all three X, Y and Z are interconvertible. That means alpha D glucose will change to open chain structure, then it will convert into beta D glucose. That means alpha D glucose and beta D glucose, they are converting into each other. They are converting into each other. they are interconvertible. That means they are interconvertible, and this process is known as mutarotation. You must have heard one word, that it is known as mutarotation. Have you heard this word, mutarotation? That conversion of alpha D glucose into beta D glucose, beta D glucose into alpha D glucose is known as mutarotation. The optical rotation of alpha D glucose is 112 degree. Optical rotation value is this much, and the value for optical rotation of beta D glucose is 18.5. Now this is optical rotation value. Now my dear students, whenever alpha D glucose is converting into beta D glucose, its degree optical rotation will decrease because this is lesser value, and whenever it is going to convert into that, its value will increase because that is more value. So at equilibrium there will be the value in between these two, and that value will be asked by examiner, and its value is, that value is 52.6. remember that. Examiner will definitely ask, what is that value? 52.6 at equilibrium. And these structures, these two structures, they are known as what? Hemiacetal. Everyone say hemiacetal pyranose ring structure. Now if I say its total number of optically active isomers, total number of optically active isomers will come 2 raised to power 4, 2 to the 4 to the 8 and 16. And the pyranose ring structures 2 raised to power, so its total number of optically active isomers 2 raised to power 5, 32, like your peristomial teats, like R teat 20, that's 32, 2, 1, 2, 3. Now this slide is clear. If it is clear to each and everyone, I want to see. Do let me know, kids, this slide is done and dusted. Hey everyone, do let me know, is this slide clear to all of you? Are you able to understand each and every point, kids? Yeah, Vigyan, no need of NCERT, because if there are people who have seen NCERT, they will let you know that everything is there of NCERT. Whatever given in NCERT, I am teaching more than NCERT, whatever is required for examination. Everything I am covering. Clear, kids? Till now, is it clear? Each and everything is clear, kids? Now, how to remember? One thing you have to keep in your brain. What's that? This structure and this structure. Because after this, I am going to tell you the cyclic Haworth representation. Till now, I have told you open chain and closed chain structure of Fischer projection. Till now, I have told you only Fischer. Now I am going to tell you Haworth representation so that you can understand each and everything. Kids, ready? Everyone ready? Now see where you have to focus. First and third carbon OH, they are on different side alpha. Same side beta. Beta like beta. Beta is always on your side. This is mother. So beta first and 3 on same side, then beta. Beta means first and 3 on same side. Will you remember? First and third carbon OH are on same side, then only beta. Beta, when you will say beta, first and third carbon on same side, then only beta. Now, let me tell you Haworth representation. Everyone ready for the Haworth representation? Everyone ready for the Haworth representation? Do let me know. Now see, Haworth representation. Haworth representation of cyclic structure of glucose. Cyclic structure of glucose. Now see what you are supposed to do. What you are supposed to do. See kids, you have to make like this. Why this space I have left, kids? Why this space I have left? This is oxygen. This is oxygen. And this oxygen is combining which carbon? Tell me which carbon, which two carbons. See the structure and do let me know. This oxygen is combining which two carbons? This oxygen is acting as a bridge in between which two carbons? Do let me know which two carbons. 1, 2, 3, 4, 5. First and fifth carbon, this oxygen is acting as a bridge. Clear? Clear? Everyone clear? And let me tell you, I have told you beta. Beta. In Hindi, beta means sun. And this third carbon OH is like mother. Mother. There is one movie. Everyone, Karan Arjun movie. There is one movie known as Karan Arjun. What happened in that movie? The village people, they have killed father of Karan and Arjun, and they have thrown out mother out of the village because all villager was thinking himself, herself to be right, and that's why all oxygen are on right hand side, and mother has been thrown on the left hand side. Gets Karan and Arjun's mother, and after many years, Tera beta teri side, his son has come to his side. Now see how this story will help you in this. Where is mother? See, first carbon, second carbon, third carbon, fourth carbon, fifth carbon. Mother was at the third carbon, and mother is always right. Mother is always right. Whether you throw on the right hand side, left hand side, mother will be at the top. So mother will always be at the top. Who is mother? See, mother is third carbon, and mother will always remember at the top. So this will be at the top. Mother's carbon is at the top. So rest of other will lie downside. Rest of others will lie downside. So rest of the OH I will put over here. Now kids, this CH2OH is not the part of ring. This CH2OH is not the part of ring, so I have kept it over there. So this is alpha D glucose. How to find out alpha D glucose? Mother will always remain at the top. This is at the top and first carbon is at the bottom. So they are opposite sides. See, this is up side of the ring and this is downside. So I've told you, when first and third carbon OH they are opposite, this will be alpha D glucose. Now how will you make beta D glucose? How will you make beta D glucose? See, Mother will remain always at the top. Mother will always be at the top. Now see kids. This is red oxygen joining which carbon? Fifth carbon. Fifth carbon and first carbon. Fifth and first carbon. Fifth and first carbon. Mother always at the top and the 1 and 3 at the top. That means on the same side. If 1 and 3 are on the same side, 1 and 3 are on the same side, then we'll say beta. Beta. Beta D glucose. If you are able to understand this much kids, you can understand everything, all these structures. If you are not able to understand, do let me know. I will tell you again and again. No worries kids. I will explain you once again, 2 times, 3 times, whatever times you need, I will tell you. But first of all, do let me know these 2 structures. If you are able to understand these 2 structures, you can understand everything. So in the chat section, do let me know kids. Do let me know kids. Heisenberg is saying once again. Okay, I will tell you once again, no problem. Yeah, Medan, Selvin, I will explain once again, no problem. No problem at all. I will explain it once again. Don't worry those who are not able to understand. Okay, no problem. Because this is the backbone for this chapter. If you are not able to understand this thing, the whole chapter will go in dust. Okay, let me tell you. See kids, see. See, just see. Everyone. First, let me draw 3 structures, 2 structures, at least 2 structures. First, open chain. Just try to understand. 2, 3, 4. Then I will draw closed chain. And then I will draw Haworth representation. Okay. Then I will draw Haworth representation. Now better you can understand. Okay. Don't worry kids. Now see kids. CHO, open chain structure, 1 first carbon, first, second, third, fourth, fifth, sixth. Okay, just you have to focus on third carbon. Once again I am telling you, just focus on the third carbon. Where is third carbon? This is your third carbon. Third carbon. This is the only OH which is on opposite side. Rest of all O are on this side. This is only on opposite side. Which carbon's OH is on opposite side? Do let me know. Third carbon. Can you keep it in even? Third carbon OH is on opposite side. And this you can say is mother. This is mother. You can treat mother. I will tell you why I am telling. This is mother. Okay. Now CH, OH and this got combined with this. Now see this oxygen. This oxygen is combining, forming the bridge in between which carbon? 1 first carbon, second, third, fourth, fifth. So this is, you can say this is bonded with both the first carbon as well as fifth carbon. I will say the oxygen says I'm yours, I'm yours, I'm yours, I'm yours, as well as I'm fifth carbon. This lally oxygen, red oxygen is saying I belong to both, I love you, you are mine. The first carbon you are mine, the fifth carbon also mine. in the closed chain. In open chain, this oxygen says, I am only yours. I am only of fifth. In the open chain structure, this oxygen says, I am only the part of the friend of fifth carbon only. But closed chain structure, this red oxygen says, I am friend of first as well as fifth. Able to understand? Everyone till now clear? Is it clear till now? And the mother, see in this, mother is on third and this is first carbon. They are opposite side. This is right hand side. This is the left hand side. If first and third carbon are opposite, first and third carbon are opposite, I will say alpha. This is alpha. Till now it's okay. This is open chain structure. This is closed chain structure. They are in equilibrium. Now tell me, till now it's clear. Before telling you the Haworth representation, till now it's there in your brain, kids. Kids, do let me know. Everyone do let me know. Till now it's clear. Heisenberg. Till now is it clear or not? Do let me know. Heisenberg. Till now it's clear or not? Now you have to answer it what I am asking. This oxygen is combining whom? This red oxygen is combining which carbon? Which two carbons are the friend of this oxygen? Which two carbons? The first and the fifth. How to find out which one is first and which one is fifth? The first is attached to this red oxygen as well as OH, the one who is directly attached to OH, and you see the fifth one is attached to CH2OH. Where I am putting CH2OH, that will become fifth. So let me put CH2OH. So this will become fifth carbon. And the one where I am putting OH, only OH, that will become first carbon. Now OH, and remember that how to put OH on this, top side or bottom side? Who will decide? I told you third carbon OH is mother, and mother will always be at the top. Mother. How mother can come down? No, mother will always be at the top. So let me draw 1, 2, 3. Mother will always remain at the top. Mother at the top of the world. This is mother, third carbon, second carbon, fourth carbon, fifth carbon. Mother will remain at the top, and mother is at this side. Then first carbon OH is opposite side. So this is up. So first carbon OH will go down. Now you are getting my point. First carbon OH will go down. Rest of others, the whole world, they will be down because they are on the same side. So H, OH, H, OH, H, OH. So this is alpha D glucose. Now is it clear? Now all three structures are clear. This is and this is same. They are same. Do let me know in the chat section. If it is clear, then show me the green hearts. Everyone, kids? Kids, you are not focusing on studies. DPP is this and that. Kids, try to understand the chapter. Is it clear, kids? Do let me know. Heisenberg, it's clear. Very good. Sahana, clear. Jyoti Jain, clear. Everyone, it's clear. Now, let me show you the structures, how to find out the structures. Okay, now see, this is the bonding. Aldehyde is bonded with alcohol and it is forming ring structure, right? Now let me tell you, glucose started crying that everyone was attacking over here. This is open chain, this is closed chain, this is open chain, this is closed chain. They are in equilibrium. So this is the mouth, open condition, carbonyl group open, and here tollens can attack, phalanx can attack, benedicts can attack. This is open close. You must have eaten popcorn in the picture hall. Popcorn. So once it is getting closed, when it is getting open, so open close, so it's mouth. This is in closed position, but remember that this is mouth. So here this is mouth. First carbon is mouth. And where if I say tollens, phalanx, benedicts, skips, they are going to attack. Where they will attack? They will attack on the mouth. This is open, closed. Open, open, closed. Here it is open form, there it is closed form. That's why they are attacking, and that's why it is acting as reducing sugar. And all reducing sugars will show mutarotation. Are you getting my point? What I'm saying, kids? What I'm saying, what I'm talking about? Glucose gets positive test with tollens reagent, phalanx solution, Benedict solution, and SIPS is a little bit difficult, so it will not show SIPS test. So generally it doesn't show SIPS test. So all these three tests it shows. And glucose, you know, if I write glucose, and if I write tollens reagent, ammonical silver nitrate solution, ammonium hydroxide plus AgNO3. Now it will form shining silver mirror, and glucose will change to gluconic acid. Glucose will undergo oxidation to form gluconic acid. Now that means this is AgNO3. This can be written like this, or it can be given like twice of AgNH3 whole twice like this. So whatever is given, it's like urgent test, plus it has gained one electron and it has converted to silver. That means it is undergoing reduction. So it is oxidizing agent. It is being oxidizing agent. That means this is reducing agent. Am I right, kids? This is being reducing agent. And this is a reducing agent. That means it is sweet in taste. So it is known as reducing sugar. And whenever, kids, there is a reducing sugar, that means it will always remain open chain, closed chain. So I would like to say all reducing sugar shows mutarotation. All monosaccharides are reducing sugars. All monosaccharides are reducing sugars, and they will show mutarotation. Till now it's clear, kids? Is it clear to each and everyone? This slide is absolutely clear. If yes, Show me the green hearts in the chat section. Let me see, kids, you are able to understand or not. Everyone. Very good evening, Vikas. Everyone, do let me know in the chat section. It's clear or not? I want to see in the chat section. It's clear. Then I would give me the green hearts. Show me the green hearts, kids. If it is clear. Now, see, kids. See. So, glucose was crying, hey, everyone is attacking on me. Everyone. So, glucose was crying. Glucose started crying. Who started crying, kids? Who started crying? Glucose. Why glucose started crying, kids? Why glucose is crying? Do let me know why glucose is crying. Because everyone is attacking on it. Everyone is attacking on it. Tolerance reagent. Cha-chow. Phalanx reagent, Dichow. Benedict's reagent, Dichow. I will kill you, I will kill you. Hey, I will kill you. You will get killed by me. Tolerance reagent is attacking Dichow. Phalanx solution is attacking Dichow. Benedict's solution is attacking ding 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 ding. Now, kids, whenever any patient is coming to hospitalized, patient is coming to hospital, then instant source of energy, this is even given to patient person. They will say, oh yeah, I am unable to eat. So instant source of energy, it is acting as instant source of energy. So he was tired that everyone was making, what is this, instant hey baba, instant source of energy. So even patients were enjoying this glucose. Anyone's father, mother is doctor, they will call this to be dextrose. They are using word dextrose, kids, dextrose, kids. Now, because of this thing, glucose decided to increase his strength. Now, two glucose decided to unite together. Who decided to get united together? Two glucose. Now see how the glucose will come in touch with each other, because when two glucose are going to combine, their power will increase, okay, and then they will be known as disaccharide. Let's see, kids. Are you able to understand? First of all, do let me know, kids. Combination of glucose. Baba is going to tell you combination of glucose, how the glucose will combine. Glucose combination. Glucose plus glucose. Glucose plus glucose. Now, what can be formed with glucose plus glucose? Everyone do let me know. What do you know glucose plus glucose? How they will combine? Just see. तुम पास आए यूं मुस्कुराए. Glucose, glucose, glucose. Hey glucose, hey glucose. Glucose is approaching. Glucose is approaching. Glucose is approaching. Glucose 2 alpha D glucose, they are approaching, okay? Who is approaching? 2-alpha D glucose. Remember that. Who is approaching? 2-alpha D glucose. But kids, do you know how to draw alpha D glucose? Whenever you want to draw alpha D glucose, remember one point. What's that? What's that? What's that? That point is always to the numbering 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Always draw the mother. Where mother was located, everyone say. Where mother was located, everyone do let me know. At the top. Third carbon at the top. Third carbon at the top. Now the whole world for alpha D glucose was down. Mother is saying, आज मैं ऊपर जमाना है नीचे, आज मैं ऊपर जमाना है नीचे. So everyone is down, everyone is down. Hey, you are down? Down, 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 down. Mother is up. Rest you people are down. Leave this. This is out of the cycle. So leave it. Out of the cycle. So leave it. आज मैं ऊपर जमाना है नीचे. Rest of people are downside and mother is at the top. Kids, all these two are alpha D glucose. Kids, do let me know. These are the two molecules of alpha D glucose. Is it clear? These two are alpha D glucose. Alpha D glucose. First of all, do let me know. The structure of alpha D glucose is clear. Then show me the green hearts. Then I will remove water. Then only I will do something. First of all, do let me know. Everyone do let me know. Till now it's clear. In the chat section, do let me know, everyone. Do let me know, kids. Do let me know, kids. Is it clear? Now, which carbon was the mouth? Can you tell me which carbon was the mouth in the chat section? I am sitting in the front of screen. Tell me which carbon is the mouth. Everyone do let me know which carbon is the mouth. First, yes, yes, everyone. Yeah. Rangaswamy. Idiyappam Murku will become Nalla Iriku. The first carbon is mouth. Very good. This is being mouth. Mouth. This is mouth. Then at the back of mouth, fourth is tail. Fourth is tail. This is mouth. Then the fourth will be tail. Okay. Mouth, tail. Kids, are you getting my point? What I am saying? My analogy will make you perfect. Mouth. This is mouth. This is mouth. And this is mouth. Okay. And this is being tail. This is being tail. And this is being tail. So when they are approaching together, then tail is coming near, mouth is coming nearer, or mouth and tail is coming nearer. Do let me know who is coming nearer. Tell me who is coming nearer. So here, this mouth and this tail will come near. This mouth and this tail will come near. And they will remove water. They will remove water. Once the water is removed, whatever the structure will get formed. See? C6, H12, O6 plus C6, H12, O6. What I will get? C12, H24, O12. Now remove water. H2O. Just remove water. O11, H22, 222 and C12. C12H22O11. This will be known as maltose. Have you got it? This is the structure of maltose. And it is having 1. This is 1. And this is 4. 1,4 glycosidic linkage. 1,4. This is known as 1,4 glycosidic linkage. Now kids, this point is clear to each and everyone. 1,4 glycosidic linkage. Now let me tell you the most important thing. This mouth is involved in the glycosidic bond, but this mouth is free or not? This mouth is involved in bond formation, but that mouth is free. Yes. And if this mouth is free, mouth means carbonyl group is free. Now it will do open close technique. It will opt for open close technique, and the tolerance reagent will come and attack on this. Tolerance, phalanx, benedicts, tolerance, phalanx, benedicts will attack on this. Now my dear students, once again it is a reducing sugar. That's why maltose is a reducing sugar. Maltose is a reducing sugar. Maltose is reducing sugar because its mouth is free. This is the reason why maltose is a reducing sugar. How many of you got it for the first time? Do let me know. Write down in the chat section those who are able to understand it for the first time. Why maltose is a reducing sugar? Why maltose is reducing sugar? Tell me kids, how many of you got it for the first time? Tell me kids, how many of you got it for the first time? Wow, thank you kids, thank you. Now see, now what they have decided, see in the story what's next. What's next? See in the story. Now they decided that this is mouth and that is mouth. This time they will combine with mouth and mouth. The water will eliminate out in this way. Now the water will eliminate out in this way. See which way? This OH and this H will combine for water formation. See, kids, just see what I'm telling you. This time what is combining? This OH and that OH. Which carbon? 2 carbons are involved. Mouth and mouth. First carbon and first carbon. Now once this is going to combine, once again the same molecular formula, C12H22O11, but this time it is known as Trehalose. What is the name? Trehalose. What is the name, kids? Trehalose. Trehalose. Remember, Trehalose. Trehalose. Now no mouth is free. This is 1 glycosidic linkage. 1 glycosidic linkage. It's 1, that's 1. So no carbonyl group is free, and that's why it is a non-reducing sugar. No carbonyl group is free. No carbonyl group is free, and that's why it is known as non-reducing sugar. Non-reducing sugar. How many of you got it? Why trehalose? Have you ever heard the name of trehalose? Why trehalose is non-reducing sugar? How many of you got it for the first time? Do let me know in the chat, kids. Thank you, Jyoti. Thank you for appreciating words. Kids, how many of you got it for the first time? I want to understand how many of you got it. Now, now, what benefit they got? What benefit they have got? Now they have become disaccharide. And on this, no tolerance phalanx can attack. Now tolerance phalanx will not attack, so they will give negative tolerance test. Trehalose will give negative tolerance test. Negative phalanx test. Right, kids? Negative tolerance and phalanx test. Now, still they were saccharide, they were sweet in taste. Everyone was dissolving in water and drinking them. They were saying, wow, you are so sweet, so sweet. So they got fed up that still people are mixing in water, and they are enjoying us that we are sweet in taste. So one day, all the alpha D glucose, the whole village people of alpha D glucose, means 200 to 1000 molecules. How many kids? How many kids? 200 to 1000 molecules. 200 to 1000 molecules of alpha D glucose combined. Now how they were standing, just see how they were standing. See, kids, everyone, how they were standing. This is your alpha D glucose. 1, 2, 3, 4, 5, 6. Mother at the top, rest at the bottom. Right, kids? Right? One more alpha D glucose, 10. Mother at the top. Mother at the top, rest like that. Okay. Mother at the top, rest like that. How many kids? How many alpha D glucose? Tell me how many alpha D glucose? Mother at the top, rest like this. How many alpha D glucose, kids? Do let me know how many alpha D glucose. Mother at the top, rest at 200 to 1000 molecules of alpha D glucose. And what they did? This is mouth, this is tail, mouth, tail, mouth, tail, mouth, tail. What will happen, kids? Do let me know what is going to happen. They will eliminate out water. 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 So linear chain of alpha D glucose. Water has been eliminated out. So polymer has been formed. What has been formed, kids? What has been formed? Do let me know. What has been formed? Linear chain of 1,4-glycosidic linkage. Linear chain of linear chain of one four glycosidic linkage and it has formed starch amylose. This is your what? This is known as kids starch amylose structure. Starch amylose, starch amylose, a polymer, a polymer known as starch amylose. Now it is a polymer. Now in this, no mouth is free. No mouth is free means no carbonyl group is free. Only one at the last, at this end, one at end. Rest of all other are not free. Except one, one this side will be free. One at that side will be free. So except one, out of 1,000, except one out of 1,000 carbonyl groups means this is not a good English. Almost all carbonyl groups are not free. Let me write down almost all carbonyl groups, almost all carbonyl groups are involved in bond formation, are involved in glycosidic linkage formation, now kids, no tolerance phalanx Benedict solution can attack. So this starch amylose will not give what it will not give, will not show what, will not show what, tolerance phalanx Benedict's test, will not show tolerance test, phalanx test, etc. So he has become polymer, polysaccharide, not sweet in taste. Now he is not sweet in taste because he has become polysaccharide. So starch amylose is not sweet in taste, not sweet in taste. Just like our chapati rice, they are not sweet in taste, and this is known as polysaccharide. Kids, till now, how many of got it? Just to let me know in the chat section. It's clear. It's done and dusted. Starch amylose, kids. Everyone, just to let me know till now you are able to understand or not. Everyone, kids. Hey, my dear students, just to let me know. Yeah, Jyoti has written one thing, kids. Jyoti has written one thing. What's that? It is water soluble. Ayya, Ingava. It is water soluble. So he started crying. Hey, what everyone is doing? Everyone is mixing starch amylose inside the water and they are drinking because I am being water soluble. Oh, he started crying. Now they started thinking how to become more stable so that we should not get dissolved in water. So alpha D glucose said, hey, call everyone from our village as well as from other village. Ayya, Pushpa jhukega nahi. So Pushpa. So he said, I will become more stronger. Call everyone from our village as well as from other village. So more people started coming. 200 plus more. Now he said, hey, we are standing like this. Just make one more line. Oh, just like in our school teacher was saying, hey, just make one more line. So he said, make one more line. Make one more line. So one more line they are going to make. See, one more line they will make. One more line. They will make one more line. See, like this. Mother at the top. Mother at the top. Mother at the top. Mother at the top. Now this is 6 carbon CH2OH, 6 carbon CH2OH, 6 carbon CH2OH, 6 carbon CH2OH, 6 carbon. Already they were forming 1,4-glycosidic linkage. Already there was 1,4-glycosidic linkage. 1,4-glycosidic was already there. Along with 1,4-glycosidic, what they did, their first carbons OH, first carbon OH and 6th carbon OH. What they did, the first carbon OH and 6th carbon OH, they combined like this. First carbon OH and 6th carbon OH, leaving 1, 1, 1. They are combining like this. First carbon OH and 6th carbon OH, they have combined like this. First carbon OH and 6 carbon OH. So along with 1,4 plus 1,6 glycosidic linkage, 1,6 glycosidic. Along with 1,4, 1,6 glycosidic. So they have formed a branch chain structure, and this is known as starch amylopectin. This is known as what, kids? Starch amylopectin. Now you got it. It is water insoluble. That was starch. Amylose was water soluble. It is water insoluble, kids. It is being water insoluble. Why it is water insoluble? Because it is branch polysaccharide. Non-reducing. It's not a sugar. It's a polysaccharide, so not a sugar. Got it? Alpha D glucose. 1,4 plus 1,6. Hey, Kirmani Archa 4. Rohit Sharma or Virat Kohli Archa 6. 4 and 6. One batsman hit it. 4 and 6. Kids got it or not? Everyone just to let me know. Everyone is able to understand or not? Kids, your liking, your understanding is my first focus. Everyone do let me know you are able to understand or not. Kids, show me green hearts if you got it. Heisenberg, very good. Very good, kids, very good. Fantastic, fantastic. Sahana, very good, very good. Now, Now, my dear students, this much you are able to understand. This much you are able to understand. Now, let me tell you cellulose. Cellulose is made up of what? Cellulose. If I talk about cellulose, kids, how will you find out cellulose structure? Cellulose. Cellulose. So cellulose is a polysaccharide. Cellulose is a polysaccharide. Made up of beta D glucose, and you know beta D glucose, kids. I have told you beta D glucose. And we human beings cannot digest cellulose. We human beings can't digest cellulose. Cellulose can be digested only by cellulose can be digested only by ruminant animals. What are ruminant animals? Who are having 4 legs. 4 legs, like buffalo, zebra, cow, etc. Because they have bacteria. Because they have bacteria in their vermiform appendix. Am I right, kids? I don't know bio, but I think this is right. Whatever I have written, that is right. Do let me know in the chat section, this is right or wrong. They have got bacteria in their, you know, bio. Those who know bio, kids, do let me know this is right or wrong. Hari Vignesh Devranjan has written yes. We digest starch. Yes, starch so we can digest, but we cannot digest cellulose. Am I right, kids? Whatever I am saying, am I right, kids? Now let me tell you the reactions of glucose. Thank you. Now let me tell you the reactions of glucose. Okay, first of all, then I will tell you structure of fructose. Or should I tell you the structure of fructose first? No, first I will tell you the reactions of glucose. Okay, glucose reactions. Okay, kids, glucose reactions. Glucose chemical reactions, because very important. Examiner will ask its number of questions from here. Examiner will definitely ask number of questions from here. So glucose chemical reactions, right, kids? Glucose chemical reactions. So see, first reaction. Before telling you the first reaction of glucose, let me tell you something that if I have got R CH2OH or R CHO or R COOH or R CH2X, where X is halogen. X is halogen. If I react with HI red phosphorus, any of these, if I react either of these, A, B, C, D, either of these three, which HI red phosphorus, we will get same product. What's that? We will get R CH3. Remember that. All they are having same carbon and we will get hydrocarbon. Our CH3 will get hydrocarbon. Then only we can understand reactions of glucose. Otherwise we won't be able to understand reactions of glucose. Till now it's clear. These four, just keep it in your brain. Now in glucose we have to deal with, out of these, this will come in your glucose and this will also come in your glucose. These two will come in your glucose, right? So we have to understand this. Okay, now see kids, if we are able to understand this one, we can easily understand each and everything. We can understand each and everything. See kids, so what I am telling you, first of all, do let me know what I am going to tell you. Glucose chemical reactions. I am going to tell you glucose chemical reactions. Glucose chemical reactions I am going to tell you kids. I am going to tell you glucose chemical reactions. Now see. Now see, this is our glucose. If I talk about glucose, CHOH whole 4 CH2OH. Now you have to help me. If I react it with HI red phosphorus, where it will attack? Where it will attack? Do let me know where it will attack. It will attack on aldehyde and it will attack on all the 5 OH. It will attack on all the 5 OH. So I will get, this will get converted into CH3. These all will get converted into CH2, 4 CH2 I will get, and this I will get 1 H over here, CH3. So I got N-hexane. Is it clear kids? Do let me know in the chat section. So glucose will give you N-hexane, normal hexane. Kids, got it or not? Do let me know in the chat section. Everyone, is it clear? Fast, kids, fast. Kids, fast, quick response I want. If you are able to, really able to understand kids. Very good, everyone is able to understand. That's something very good kids. That's nice. Now see, if I react glucose with tolerance reagent, so I will get tolerance test. But if I react glucose with hydrogen cyanide, then what I will get? If I react glucose with hydrogen cyanide, this is glucose, and if I am going to react with hydrogen cyanide, then how the reaction will take place? See, Hasina, delta negative, delta positive, delta negative, delta positive. So how they will react kids? This Cn negative will go and attack from both sides on this carbon, and H plus will attack on oxygen negative. So what you will get? We will get kids CH O on O, we will get H, and here cyanide. Rest of these OH will remain as such, and this will become CH2OH. The name of this compound will be known as glucose cyanhydrin. Remember that. What do you call it? Glucose cyanhydrin. And this glucose cyanhydrin will behave as synthetic intermediate. What? Synthetic intermediate. In the examination, each and every point will come from here only. Now, if I react it with water in acidic medium, what will happen? If I react it with water in acidic medium, then only cyanide group will be affected. This cyanide will convert into COOH. Then I will get C. CHOH will remain like this. Only the effect will be on cyanide. Cyanide will change into COH. Rest of the things will remain as it is. CHOH whole 4, CH2OH. In this way, we have increased one carbon. We have increased one carbon. Now, if I do the reaction of this compound with B2H6, if I react it with B2H6 acidic medium, then this B2H6 will affect only COH group. COH will convert into primary alcohol. Then the reaction will be C. CHOH, CH, OH whole 4, CHOH whole 4, CH2OH, and this carbon yellow one will convert into CH2OH. Now kids, how many carbons we have got? We were having 6 carbons, C6, H12O6. Now right now we are having how many carbons? 4, 5, 6, 7 carbons. 7 carbon compound we have got, and in this way there is ascent of series, step growth, ascent of series, ascent of series. We have increased carbon. How many of you got it? Show me in green signal in the chat section if you are able to understand, kids, how to increase the carbon. How to increase the carbon, kids? Do let me know in the chat section if you are able to understand. I want to see in the chat section that, my dear students, everyone got it. Everyone is able to understand. Now, let me tell you one reaction which is not given in the NCERT. But once you tell me that you are able to understand, then only I will tell you the reaction which is not given. Assalamu alaikum, Muhammad Yaha. I will show you, I will tell you that reaction which is not given in the NCERT. I will show you that reaction, kids. Okay, everyone got it. Now see, the missing part of NCERT. Now let me show you the missing reactions of NCERT. Ready? Missing part of NCERT. Let me tell you, missing part of NCERT. This is known as Osazone formation. What is? What I am going to tell you? Osazone formation. What is Osazone? Before I start, I will tell you this Osazone is yellow PPT. And the structure of Osazone, we will get Osazone from 3 compounds. Glucosazone, if I say glucosazone, obtained from glucose. Fructosazone, obtained from fructose. And mannosazone, obtained from mannose. All they are yellow colored. First point, all they are yellow PPT. All three are yellow PPT. All three are what? All three are yellow PPT, and all three will have same structure, and their common name is Osazone. So Osazone is the common name. Osazone is what? Osazone is common name. Common name. And this common name is for whether I say glucosazone, whether I say glucosazone, whether I say fructosazone, whether I say mannosazone, all their structure is being same. All their structure is being same. First of all, do let me know till now you are able to understand. Very, very important. It holds really a hell lot of weightage. All the three, they will form same structure. Now let me tell you how they will form, how will they get formed. It is very, very important, but it is missing in NCERT. It is not given in NCERT. Let me tell you. Let me teach you, kids. If I draw glucose, then I will tell you what type of questions they will ask. Think and see it properly, right? CHOH, CHOH whole thrice, CH2OH. Now 1, 2, 3, 5, 6. Now if you react it with phenylhydrazine, what is phenylhydrazine? C6H5 NH2. This is phenylhydrazine. Phenylhydrazine, kids, it's being phenylhydrazine. Now you know very well, the water will eliminate out. Kids, are you getting my point? Water will eliminate out like this. 1 mole, because they will ask side product also. 1 mole of water has been eliminated out. This was glucose. Glucose. This is phenylhydrazine. Water has eliminated out. The structure you will get like this. Just see. CH double bond N, NH, C6H5, CH, OH, CHOH whole thrice, CH2OH. Now 1 more mole of phenylhydrazine will come. 1 more mole. Now see. Once 1 more mole of phenylhydrazine has come, let's see what is going to happen. C6H5 NH2. Now kids, 1 more mole of phenylhydrazine. Do you think that this phenylhydrazine can react? There is no carbonyl group. Nulla, illa. La. Carbonyl group is La. Then how it will attack? Where it will attack? It cannot attack. It seems to be like this, that it cannot attack. It's looking like that it can't attack. It is not having any chance to attack. Then now see what he will do. He is such a fantastic compound that he will eliminate out ammonia. H plus NH2 negative, ammonia will eliminate out. And now this positive part will take away this as negative. This will also go. Now see kids, here oxygen will develop negative charge and this will develop positive. They will form a bond. So see what will get formed. compound CH double bond N NH C6H5, and this will convert into C double bond O, and let me write down ammonia got released along with ammonia. This has become aniline NH2 C6H5. So how many are the side product? Water is the side product, ammonia is the side product, aniline is the side product. These are side products, remember that. Now CHOH whole thrice CH2OH. Now this has developed. Once again phenylhydrazine will come. Once again phenylhydrazine will come, kids. C6H5 NH NH2. Now water will eliminate out. Water will eliminate out. Now see, kids, what you will get. Once again water has eliminated out. Now you will get, kids, CH double bond N NH C6H5, C double bond N NH C6H5, CHOH whole thrice CH2OH. This is your dihydrazone. Di because 2 hydrazone, dihydrazone, and this is only osazone. Now kids, further reaction with phenylhydrazine cannot take place because it has become solid, yellow crystalline solid. It has become yellow crystalline solid. Now examiner will ask that how many phenylhydrazines are consumed. 1, 2, 3. Total 3 phenylhydrazines have been consumed, right? Total how many phenylhydrazines? Total 3 phenylhydrazines got consumed, right kids? What are the side products? Water, ammonia and aniline. Just see to it. Then I will tell you why fructose is also forming the same structure. I will let you know, kids. Kids, first of all, see to it. Everyone, are you able to understand or not? Do let me know first of all. Everyone, just do let me know you got it or not. Do let me know, kids. Thank you, Jyoti Jain. Thank you. Thank you. Now, I will show you the fructose and mannose. They are also going to form the same type of compound. Why? Why they will form the same type of compound? I will show you, kids, right? Let me show you. Let me show you how the fructose will form the same structure. The same structure will get formed by fructose also and mannose also. Okay, let me show you why fructose is going to form the same structure. See, if I say this is being fructose CH2OH, C double bond O, CHOH whole thrice, CH2OH. Now phenylhydrazine will come, C6H5, NH, NH2. Now where it will react? This is the carbonyl group. Water will eliminate out. Water will eliminate out. So what you will get? This is fructose. Everyone tell me what you will get. Fructose phenylhydrazone. We will get fructose phenylhydrazone. Am I right, kids? I will get fructose phenylhydrazone. Now one more molecule of phenylhydrazine will come. One more molecule of phenylhydrazine will come. Now kids, what they will eliminate out, you know very well what they will eliminate out. This will eliminate out ammonia, and this will eliminate out this hydrogen, and aniline will eliminate out. Am I right, kids? So in this way ammonia and aniline will get eliminated out. So you will get compound like this. Now you know very well, first he has made this carbonyl group, he has developed this carbonyl group, and now he will attack on this. Who? Phenylhydrazine. Now you know phenylhydrazine, one more phenylhydrazine will attack on this. Water will eliminate out. Now see the structure. Everyone just focus on the structure. What structure you are going to get? CH double bond N, NH, C6H5, C double bond N, NH, C6H5, rest CH, OH whole thrice, CH2OH, and this is osazone, and this osazone, or you can say fructosazone, is same as you see the osazone we have got from glucose. The glucosazone you can compare. Are they same? Are they same or not? Just to let me know, are they same or not? Everyone just to let me know, they are exactly same or not? The two structures are exactly same or not, kids? Thank you, Deepak Kumar. Tell me, kids. Saucy is there. Welcome, Saucy. Take care of your health, Saucy. Sahana, thank you. Jyoti Jain, Hazenberg, everyone. Now see, what question they will ask, what type of question they will ask. But before giving you question, let me tell you something. Before giving you question, I would like to tell you something. See, kids. First, try to understand the structure of glucose, difference between the structure of glucose. Then only you can do that question. Glucose. I want that everyone can do that question. Mannose, galactose, fructose. These are the 4 compounds, and I will draw their structures. You have to understand the difference, then you can do that question. Let me draw that structure, okay? Now, if you see the osazone, first of all, try to understand where is this difference. See, if I talk about difference, then I would like to say that here the difference is on this carbon, here the difference is on this carbon. Am I right? First, try to see. Everyone, just see. Then I will tell you each and every technique. Then I will tell you each and every technique. Kids, just see first. Till now, just try to see, kids. Then I will tell you the technique. Now see how to remember it. How to remember it. This is the third carbon, and third carbon was mother. Third carbon was mother, right? Third carbon was mother, right, kids? Am I right or not? First of all, do let me know. Third carbon was mother. Third carbon was mother. Just upside of third carbon, there is difference. And in this, just down of third carbon, there is difference. Mannose. Nose is at the top. Nose is at top. And galactose, toes is down, toes are down. So just up of mother, nose, down of mother, toes, toes, galactose, mannose. Got it? First of all, do let me know in the chat section. Till now it's clear. Mannose, nose is always at the top and toes is down. Nose is top, toes are down. This thing is clear, kids. Do let me know first of all. Till now it's clear or not? Smart boy, welcome. Thank you, Dream. Thank you, Dream. Everyone, first of all, do let me know till now it's clear or not. The trick is awesome or not. HSP's trick is awesome. Now see, this is the trick. Trick is awesome. Awesome trick. Now kids, just try to see the structure of this. Only the structure is involving first and second carbon. Except first and second carbon, if rest of the part is same, this part is same, if this part is same, then the osazone will remain same. Now see, if I say in this, this and that, how many compounds the other than 2 carbon the part is same? Other than 2 carbon the part is same. How many? And how many other than 2 carbon? Leave 2 carbon and rest of the part is same. In this, and in this. 4, 5, 6, 3, 4, 5, 6. This part is same or not? First of all, do let me know. Glucose, mannose and fructose. Rest of the part is same, because here it is different. It is different. So it will form different type. Rest of this and fructose will form same type of osazone. Are you getting my point? So the question will be asked in the exam. Question will be asked in the exam. That question will be on reaction with, question is on reaction with excess of phenylhydrazine on reaction with excess of phenylhydrazine, which will form different compound, Options are first option, A option is glucose, B option is fructose, C option is mannose, D option is galactose. D is galactose. Yes. Do let me know in the chat section what's your answer. Everyone, do let me know in the chat section what's your answer. Let me see who is going to give the correct answer for this question. I am waiting. Baba is waiting for your answer. Sahana has given the correct answer. Sahana has given absolutely correct answer. Riya Desai, Pragnya Botke and Madhu Darshani, they have given the correct answer. Galactose will give you different answer. That's why first of all I have taught you, and then only I have given the question. Galactose is differing on 4th carbon, differing in configuration at 4th carbon. Now, let me tell you, my dear students, one more thing, what they can ask. See, if I say glucose and mannose are What is the relation in between glucose and mannose? They will give you question. Relation between glucose and mannose. Tell me which one is correct. A is they are anomers. B is they are epimers. C is they are enantiomers. D is all of these. Do let me know in the chat section what's your answer. I'm waiting for your answer, kids. I'm waiting for your answer. Do let me know in the chat section what's your answer. If you are able to solve all these questions, you will get best rank. Let me know in the chat section. Yes, the correct answer is they are Epimers. They are not enantiomers. Why they are not enantiomers? Because enantiomers are non-superimposable mirror images. Enantiomers are, if I say enantiomers are non-superimposable mirror images of each other. But see, kids, glucose and mannose, they are not mirror images. They are differing in the orientation of OH at one carbon. They are not mirror images. These two are not mirror images. These two are not mirror images, kids. These two are not mirror images. Remember that these two are not mirror images. Clear, or should I tell you more? Should I tell you more, or is it clear? First of all, do let me know. Is it clear, or should I tell you more? It got clear, then show me epimer. I will tell you what is epimer. I will tell you epimer. Okay, let me tell you in the detail. First of all, then only you can understand, kids. That's why Baba is Baba. Baba will let you know each and everything. Baba will let you know each and everything, kids. You have to tell me that, yes. Let me tell you. Let me tell you. Biomolecules isomerism. Biomolecules isomerism. Okay, biomolecules isomerism. First, try to understand what do you mean by epimers. First of all, try to understand diastereomers. Diastereomers. Those stereoisomers which are not mirror images of each other, which are not they are known as diastereomers, right, kids? Or I can say, or those stereoisomers which are not enantiomers, which are not enantiomers. For example, let me tell you, for example, just see, for example, glucose and mannose and galactose, they are not mirror images of each other, because in mannose second carbon OH is lying on the left hand side and galactose fourth carbon OH is lying on the left hand side. Are you getting my point, kids? Everyone getting my point? Till now it's clear. Now let me tell you what are epimers. You are interested in epimers, right? Epimers are a special type of diastereomers which differ in the configuration of only only one hydroxyl group. Which differ in the orientation of only one hydroxyl group, just like example, glucose and mannose. Glucose and mannose. What is the difference in between glucose and mannose? If I talk about glucose and mannose is differing in the orientation of OH at second carbon. Its second carbon's OH is on left hand side, its second carbon's OH is on right hand side. Let me draw. Now see, this is glucose, that is mannose. Where it is differing? It is having different configuration on this carbon. See, its OH is on right hand side, its OH is on left hand side. Rest of the whole structure is same. Only at this carbon it is having different configuration. Are you getting my point? Just to let me know in the chat section you are able to understand or not. Then only I can move ahead. First of all, do let me know till now it's clear or not. Everyone just do let me know it's clear or not till now. Nose and toes, yes. Break I will give at after 10 minutes. After 10 minutes I will give you the break, okay? After 10 minutes. After 10 minutes I will give the break. At 7:30. At 7:30 I will give you the break, right? Okay, now see, Now it is all about anomers. What are anomers? See, anomers. These are special type of Epimers. Now kids, see, Epimers were special type of diastomers, and these are special type of Epimers. These differ in the orientation of only one OH, that is hydroxyl group. The hydroxyl group must be involved in the ring formation. Involved in what? Involved in ring formation. This hydroxyl group should be involved in ring formation. So you know, do you know any such type of example? So example I will tell you. For example, alpha D glucose and beta D glucose. Do you remember? Alpha D glucose and beta D glucose, kids. Do you remember or not? Do you remember or not? Alpha D glucose and beta D glucose. This thing you know. Do let me know in the chat section. Then I will move ahead. Then I will give you a question. If you understand this thing, what I have written. Thank you, Moideen Sullivan. Kids, do let me know first of all. So in this way, first I will tell you, then I will ask question. First I will tell you the whole thing because it is looking like idiyappam murukku, but I will make it romba sulbham. Then only I will give question. Idiyappam murukku thing, let me make it romba sulbham, then only I will give question. So I would like to say all anomers are always what? Epimers. And all epimers are always diastomers. And all diastomers are always configurational isomers. And all configurational isomers are always isomers. So this in sense is indicating that all anomers are epimers. That means all anomers are diastomers. All anomers will be configurational isomers, and this is indicating that all epimers will be diastomers. All epimers will be configurational isomers. So diastomers will always be configurational isomer, but reverse is not true. What? Reverse is not true. Kids, is it clear? Do let me know in the chat section. Is it clear to each and every one of you? Thank you, Dream TPC. Thank you. Mediappa Murku has become Rombasulvam. That's great. Now, once if you are able to solve the question, then only I will say, yeah, it has become Rombasulvam. Medhuva, you will be able to understand each and everything now. No one will say chemistry pedikyaradu customer. Everyone will say it's Rombasulvam. So Medhuva, you will be able to understand each and everything. But time is required. Now, see, I am going to give you a question. Then only we can say that, yes, you got it. Now, the question is, now you know these two structures, you know their name also. One is being alpha D glucose, another one is beta D glucose. Now the question is, alpha D glucose and beta D glucose are, first option, anomers, second option, epimers, third option, diastereomers, D option, stereoisomers, E option, all of these. So I am waiting for your answer in the chat section. Do let me know in the chat section what's your answer, kids. See my all notes, then only try to give the answer, kids. Don't give answer easily, kids. See to it. See my notes, kids. Don't give. No hurry. Just see to it, kids, and then only answer it. Only one answer is correct, and the answer given by Sahana. Sahana's answer is correct. Only Sahana has given the correct answer, kids. They are anomers. They are anomers. Once they are anomers, and all anomers are always, I taught you, if you are saying they are anomers, so I have told you all anomers are what? All anomers are what? All anomers are this. That means you are not able to understand. So I have to tell you in another way. I have to tell you in another way so that next time you should not do any mistake. Anomers. Let me draw anomers. These are anomers. All anomers are always epimers. Suppose you live in Tamil Nadu. So you live in Tamil Nadu, so you live in India. And those who are living in India, They are living in Asia. They are living in Asia, diastomers. So let me tell you, all Tamilians, Tamil people are Indian people, and all Tamil and Indian people are Asian people. And let me draw. This is world. World means configurational isomer. And if I say this is universe, this is universe. Now kids, do let me know, all Tamil Nadu people, if I say this is Tamil Nadu, if I say this is India, if I say this is Asia, if I say this is world, if I say this is universe is isomers, isomers is universe. So all Tamil Nadu people are Indian, all Tamil Nadu people are in Asia, all Tamil Nadu people are in world, all Tamil Nadu people are in universe, but reverse is not true. Now, will it help you? Do let me know in the chat section. Now, will it help you, kids? Now, it is giving something good analogy, kids. You got good analogy or not? Just to let me know. Everyone, just to let me know you got good analogy or not. Now, it's 7:30. Let's meet at 8. Okay, let's meet at 8, kids. Break time. So let's meet at 8. Is it fine, kids? Come with full on energy, come with full ATPs. Will you, kids, and call your friends? Everyone come with full ATPs and call your friends also, because after this break Baba will tell you very awesome thing. Say promise, make a promise. Everyone will come with full ATPs. Make a promise, kids. Okay. Let's meet with full of ATPs, right? Welcome back, kids. Are you there, kids? Just to let me know. Everyone is over there. How is the Josh? Are you with full on energy, kids? Just to let me know. Show me fire symbol in the chat section if you're ready. Now I'm going to start with glucose other reactions, because first reaction I've told you the formation of N-hexane. The second reaction I've told you that reaction with hydrogen cyanide, and third reaction glucose that formed yellow crystalline solid, that glucosazone, fructosazone, osazone. All these things I've told you. Now kids, let's start with other reactions of glucose. In between that I have told you isomerism in glucose. Now glucose other chemical reactions. My dear students, I will not take more than 70 to 80 minutes. In that it will get completed. Glucose, fructose, and amino acids trick I will give you, which is being the most basic amino acid, what are being essential amino acids. I will give you the trick for that. Vitamins, water soluble, fat soluble, and sensitive disease, I will give you the trick for that. And DNA, RNA, you know very well, but then also I will give you one trick. Okay, kids? First of all, do let me know how is the Josh. Good. Now, glucose, my dear friends, if I talk about glucose, now, if anyone is saying that this glucose will react with how many molecules of acetyl chloride? Either they will give you acetyl chloride, CH3, COCl, or they can give you, in place of acetyl chloride, they can give you acetic anhydride. Either acetyl chloride, or they will give you what? Or they will give you acetic anhydride. They will give you acetic anhydride. Now, first of all, let me tell you how they react with alcohol. Then only you can find out how they are going to react with glucose. If we don't know how they are going to react with alcohol, then the nature, we can't find out the nature, then we can't do anything. See, if there is ROH and if I take acetyl chloride, that is CH3, COCl. Now see, one OH will get replaced like HCl. It will go like this. HCl will eliminate out, and what product you will get? You will get product like ROCOCH3 plus HCl. You got ester. You got ester. Now, if I say the same alcohol and acetic anhydride is going to react. Acetic anhydride, if I react it with acetic anhydride, CH3, C double bond O, O, C double bond O, CH3. If I react with this, so see kids, this will eliminate out like this. It will eliminate out like this H, and it will go like this. See kids, it will move like this. This bond will go. Now, just focus over here, O negative and this carbonyl positive. Why this carbonyl positive? Because it will stabilize by back bonding. That is known as two atom resonance. So, they are good leaving group. Here, this will element out as acetic acid. So, once again, you will get same product ester, and the side product will be acetic acid. If you are able to understand, do let me know. If you are not able to understand, then do let me know. So, this is the reaction in the same same product you will get, that is being ester. Do let me know in the chat section you are able to understand or not, kids. Do let me know in the chat section that you got it. If you got it, do let me know, kids. Everyone, you got it or not? Just do let me know, kids. It's clear or not to each and everyone? Everyone do let me know, is it clear or not? Kids, everyone do let me know. Everyone do let me know, kids. Yes, it's clear. Now see, kids. Now see. Now if it is going to react with glucose, now tell me, if one OH is there, one acetyl is reacting. In glucose, how many OH are there? In glucose, there are 5 hydroxyl groups. So how many acetyl will react with this glucose? So the answer will come out that with glucose, that is CH double bond O, CHOH whole 4 and CH2OH. There are total 5 hydroxyl groups. Now there are 5 hydroxyl groups, that means it will react with 5 acetyl. Remember that its name is acetyl. Acetyl is the journal name. Remember that. What? Acetyl is journal name and IUPAC name is 1,2-ethanoyl chloride. Ethanoyl chloride. So 5 HCl will eliminate out and you will get penta-acetyl glucose. How it will look like penta-acetyl glucose, kids? CH double bond O, CH O, CO, CH3 whole 4, CH2 O, CO, CH3. Its name is penta-acetyl glucose. Is it clear to all of you, kids? If yes, show me green signal in the chat section. I want to see green signal in the chat section, kids. Is it clear? Everyone does just to let me know. Is it clear to all of you? Is it being clear to each and everyone? Everyone do let me know. Is it clear? Everyone show me green hearts if it is clear to each and everyone. Now let me tell you the oxidation of glucose and fructose. Now let me tell you the oxidation of glucose and fructose. Oxidation of glucose and fructose. So if I say, this is very, very important, kids, there is glucose, now if I react glucose with mild oxidizing agent. Mild oxidizing agent is bromine water. What is the color of bromine water? Reddish brown. Br2 water. Remember that, Br2 water. This is MOA. MOA stands for what? Mild oxidizing agent. So it will attack only on CHO part. CHO part will be attacked and this will get converted into COOH. Rest of the part will remain as such. Rest of the part will remain as such. Now this is known as gluconic acid. Gluconic acid. My dear students, it is known as gluconic acid. And remember that I'm going to tell you one very, very important thing, that same reaction if you are carrying out with fructose, fructose will not show this reaction. Get C. Fructose will not show this oxidation process. Very, very important thing I am going to tell you. This oxidation process is not shown by fructose. And how it is very, very important, let me tell you, kids. Why it is being very, very important, let me tell you. Fructose, if I write down fructose is a ketone. Fructose is what? Fructose is your ketone. Fructose is a ketone. Very, very important reaction, kids. Fructose is a ketone. That's why it is known as ketohexose. And ketones are stable. Ketones are less reactive than aldehydes. Remember that, than aldehydes. So if you add bromine water, reddish brown bromine water, no reaction. No reaction, kids. No reaction. There will be no reaction. Now, how will you find out that there is no reaction? Because we cannot see with our naked eye whether the reaction is taking place or not. We cannot see this with our naked eye. Then who will let you know? Because, kids, reddish brown color decolorize over here. Color will decolorize. Bromine water color will decolorize. This thing you have to note down over here, that reddish bromine will get decolorized in this case. It will get decolorized. Here the bromine reddish color will get decolorized. But in that case, in this case, color will not decolorize. Color will not decolorized, and this is the most important thing. This will show that color will not decolorized. Colorized over here, colorized. What is this, kids? Color will not decolorize. Color will not decolorized. Let's see whether they are going to write. Yeah, decolorized. Color will not decolorize, kids. Color will not decolorized. Okay, kids, is it fine? Nalla iriku? Color will not decolorize. That is indicating that no reaction is taking place, and this is the distinguishing test in between glucose and fructose. This is the only most important, the one and only one distinguishing test, and that's why this is very, very important. A distinguishing test, a distinguishing test in between glucose and fructose. Now, kids, everyone will ask one question. Sir, can't be used tolerance test, Phalenx test, because tolerance test and Phalenx test is given by aldehyde only. So why can't we use that test? My dear students, let me tell you the most important thing, very, very important thing, which holds a lot of weightage. Kids, once I have written that all monosaccharides gives positive tolerance test, positive Phalenx test, positive Benedict's test, Now kids, question arises, sir, it's okay that glucose gives positive tolerance test, fine, I can understand. Mannose give this test, okay, I can understand. Galactose give this test, that also I can understand, because all they are aldohexose, means aldehydes. But sir, why fructose is giving this test? I am unable to understand why fructose is giving this test, even though the fructose is being ketone, ketohexose. Now kids, this is $1 million question. Why fructose being ketohexose give this test? Now how many of you want to understand the reason for this? Why? Even though it is being ketone, then why it is giving tolerance test? How many of you want to understand, kids? Do let me know in the chat section. How many of you want to know the reason for it, exact reason for it, kids? Do let me know, then I will tell you, explain it in the chat section. Do let me know how many of you really want to know that why fructose give this test, kids. How many of you are really interested in understanding why fructose? Yeah, all concept, Marvel Home, all concept. Yes, now let me show you, kids. Not only fructose, I would like to say all this type of ketones, CH2OH, C double bond O, R, any ketone like this, how will you remember? This is ketone, this is alpha hydroxy ketone. All ketones like this, alpha hydroxy ketone, this is known as alpha hydroxy ketone. All alpha hydroxy ketones will give positive tolerance Felix and Benedict's test. Its shortcut is TT, its shortcut is FT, its shortcut is BT. Will you remember? TT, FT, BT. Now let me tell you the reason. Let me show you the reason, the most important thing, kids, because for examination this is very, very important, and all examination will ask this question. And see, Baba is going to tell you the reason for it. This is your fructose. Just pay attention, everyone. This is your fructose. I will take only 2 carbons, rest of the part let me take as R, okay? Let me take it to be R. This is fructose. Now, if I add tolerance reagent, then I have to add ammonium hydroxide plus AgNO3, ammonical silver nitrate. This basic medium, what it will do, kids? This OH negative will do the tautomerization. What it will do? It will do tautomerization. It will do tautomerization. How tautomerization will take place? See, the hydrogen which is attached on 1, 2, 3, it will come to third atom. It will come to third atom. From there, it will come over here, and the double bond will shift in between 1 and 2. Sorry, hydrogen will come to 3. Oh, this hydrogen, no double bond, so wrong. So this hydrogen will come because there is double bond, 1, 2, 3. This hydrogen will come over here. This hydrogen will come from 1 to 3, and double bond will get shifted in 1 and 2 in between. Now see, you will get tautomer of this. The tautomer is CHOH double bond C and OH R. Are you getting my point? For double bond we will write ene and 2OH diol. Ene diol, remember that. Examiner will ask enediol. This compound is very, very important. Examiner will ask enediol. Now once again tautomerism will take place. Once again tautomerism will take place. Now see kids, during tautomerization what is going to happen? Now double bond is over here, 1, 2, 3. From 1, this hydrogen will shift to third atom, 1, 2, 3. So hydrogen will come over here. From 1 to 3, hydrogen will get shifted and double bond will come in between 1 and 2. Double bond will come in between 1 and 2. The mechanism of tautomerization already I have told you. Now see, this carbon is being sp2 hybridized. Remember that. So this hydrogen will come from this side also and that will come from that side also. Both the side it will come because it is sp2 hybridized. So hydrogen will come into its life from right hand side as well as from left hand side. Both the sides it will come. So two types of compounds will get formed. What are they? CH double bond O. C, it will attack on this side. So CH, OH and R. And if it is coming from this side, then CH double bond O, CH, OH, R. Do you remember these compounds? One is glucose, another one is what? Mannose, and both of them are aldehydes. Actually, frankly speaking, this ketone has not given this test or these tests. Actually, Tollens test, Phalanx test, Vanadic test is given by these aldehydes. But the basic medium, this basic medium has converted ketone into what? Has converted this ketone into aldehyde. In this way, all the ketones of this type, in basic medium will get converted into what? Will get converted into aldehyde like this. Aldehyde like this. Am I right, kids? So they will give this test, and this whole process is known as Lowry de Bruijn van Ekensteen rearrangement. What they will be known as? Kids, what the name I said? Lowry de Bruijn van Ekensteen rearrangement. Have you heard the name? Let me write down, otherwise you won't be able to understand. The name is, this whole rearrangement is known as Lowry, big name, Lowry de Bruijn van Ekensteen rearrangement reaction. What I said? Lowry de Bruijn van Ekensteen rearrangement. The whole process is known as Lowry de Bruijn van Ekensteen rearrangement. This is the name of this process. Remember, my dear students, I hope that everyone of you got it. Kids, show me the green hearts if you really like this thing, the reason, the explanation of this, kids. Thank you, Medico. Thank you. Wow, Jyoti. Thank you. Kids, everyone, just to let me know that really you are enjoying. Hey, mera pyara bachcha, kiddo kids. Everyone, just to let me know you are really enjoying it. Now, let me show you some other reactions of glucose the revision में मजा आ रहा है मेडिको, very good. Kindly explain fructose ketone, sir, please. Fructose ketone. So this is R part, if I write, Shalivan, Moidan, this is fructose only. See, the rest of the part of fructose I have not written. Moideen, Shalvan, this you can take, this is fructose only. If you write R as full, there is no change. Just do let me know you got it. Now, kids, let me tell you, oxidation with a strong oxidizing agent. I have taken mild oxidizing agent. Now, if I am going to take a strong oxidizing agent, so what will happen? See, this is your glucose, CHOH whole 4, CH2OH. Now, if I take, I have taken, more mild oxidizing agent like Br2 water I have taken, or tolerance test I am doing, or phalanx test I am doing, or Benedict's test I am doing any of these, I will get gluconic acid, because CHO will convert into COH, rest of the part will remain same, nothing will happen. But at the same time, I am going to take a strong oxidizing agent. That was mild oxidizing agent. If I take SOA like K-amino4 acidic medium, or I can take orange color potassium dichromate K2 Cr2O7 acidic medium, or I can take concentrated HNO3, any of these things I can take. Now their effect will be over here, effect will be over here. Now both of these two will get oxidized, so I will get COOH, CHOH whole 4 and COOH. Its name is glucaric acid. Its name was gluconic acid. Nick, remember that Nick, N, here Rick, difference in Nick and Rick. See, Nick, here is Nick, here is Rick, gluconic acid. Its another name is, second name of this compound is, saccharic acid, its name is saccharic acid. Its second name is saccharic acid. Remember that. We will get two compounds. Now, if fructose is treated with MOA and SOA, you remember that? MOA, what they will do? See, kids, fructose. If I take fructose, CH2OH, C double bond O, CHOH whole 4, so not whole 4, whole 3, CH2OH, this is being fructose, kids. This is being fructose. Now if I treat with bromine water, nothing will happen. This you know very well. Bromine water, no reaction, no decolorization, no reaction. But if I take tolerance reagent, tolerance test, or phalanx test, or Benedict's test, then definitely it will undergo oxidation. Positive test you will get. Now my dear students, so what will be the product? Definitely you will get glucose, and that will convert into gluconic acid. So very simple. Gluconic acid plus silver mirror, or whatever the color, this will give silver mirror, this will give silver mirror. If I say what you will get in phalanx test, do let me know. Phalanx test will give red color of Cu2O, cuprous oxide, you will get cuprous oxide, red color. And here also Benedict's test also you will get the same thing. Now If I use concentrated HNO3, then what you will get? This is being SOA. Both of them, they are being MOA. This was MOA, mild oxidizing agent. These were also MOA. But if I use SOA, that is concentrated HNO3, then it will follow Popop's rule. Do you remember Popop's rule, kids? Popop's rule says, those who don't understand, that this carbonyl will go with the one who has having less number of carbon atoms. See, this carbonyl group will go or will remain friend of that alkyl group which is having less carbon. It is having 1 carbon, it is having 4 carbons, so it will break from here. This is Popop's rule. What is Popop's rule? Carbonyl will remain bonded with the one who is having less number of carbon atoms. This is having just 1. So 2 carbons acid, you will get COOH. COOH, its name is being oxalic acid. Oxalic acid, and that is of 4 carbon. This will get undergo oxidation and its 1 OH will undergo oxidation. So you will get COOH, CHOH whole twice. And if you remember this name, we have studied during isomerization. Tartaric acid. This is tartaric acid. Now kids, this much is clear? If yes, do let me know in the chat section that you got it, kids. Do let me know, kids. Everyone just do let me know. Yes, Medico, very good. Jyoti, very good. Hari Vignesh, fantastic. Dream, TMC, fantastic, kids. Really, you are doing very good job, kids. Fantastic, fantastic, kids. Fantastic. But do let me know that everything is clear. Till now, everything is fit and fine, kids. Now, after this, one reaction is left, that is reduction. Only one reaction, that is being reduction. So let me tell you reduction of glucose and fructose. Reduction of glucose and fructose, kids. Let me tell you reduction of glucose and fructose. Reduction. Now kids, if I take glucose, this is your glucose. Now reduction of only aldehyde can take place. Rest of all other groups are already reduced. So if I reduce it with NaBH4, acidic medium, or I can take LiAlH4, ether, then this will get affected. This one, CHO will convert into CH2OH. This will get converted into CH2OH. Rest of others will remain same. Rest of others will remain same. Just a second, kids. Just a second, kids. CHOH whole 4, CH2OH. Its name is sorbitol. Very, very important compound, kids. Sorbitol. Why it is being important? Because nowadays, you know, in the market, sugar-free sweets are there. These sugar-free sweets, they contain sweetening agent, but they are not having calorific value. That is the sorbitol only, a remedy for diabetic patients. A remedy for what? It's a remedy for diabetic patients. Diabetic patients. Now, my dear students, if the same reaction, if I would have carried out with fructose, then I will get what? Just think about it, what I will get. The same reaction I am going to carry out with fructose. So are you ready? Is everyone ready? Just to let me know in the chat section. I am going to tell you the same reaction. If I do with fructose, what I will get. I am at the in front of this laptop. Yeah, PDF I will share. PDF I will. Yeah, oh my God, Jyoti Jain. Wow, kids, you are Romba Sulvam. Fantastic, fantastic, fantastic. Jyoti Jain has written reduction of fructose. Just see fructose. CH2OH is there. C double bond O is there. CHOH whole thrice. CH2OH. Now see, this is sp2 hybridized carbon, and if this is undergoing reduction, it can be OH on this side and OH can be on that side. So you will get two types of products. You will get definitely two types of products. See how? CH2OH, CHOH, once OH this side, and second time you can get OH on this side. So you will get CH2OH, CHOH, CHOH whole thrice, CH2OH. Now one is the same compound, its name is sorbitol, but its name is mannitol. Why this has happened? Because this is sp2, so the attack can be this side as well as the attack can be from this side. Equal amount of attack will be possible. So these are all the reactions of glucose and fructose. Now only one thing is left, that structure of fructose. But before moving towards that, I have to tell you, glucose, when reacts with what? Ayayyo, not the glucose. Lactose. How you will get lactose? The disaccharide lactose. That is very, very important, kids. Anyone can tell me in the chat, how will you get lactose? This is very, very important. Oh, great. Lactose, kids. What is lactose and how will you get lactose? Wow, kids. Lactose is very, very important. Very, very important. I would like to say lactose is very, very important. Lactose. Lactose is a disaccharide. Its molecular formula is also C12H22O11. Now, how to remember lactose? This is the story of my class 6th. In my class, there was one girl. I remember all the girls, but one girl was very, very special. Her name was Bebo, and she was always having glucose powder, that powder, milk powder, always inside mouth. Then what I did, I tried to rusticate her, and she has gone to Mumbai and she has become famous actress Bebo. And now Bebo. Now see, लाख टके की बेबो. The trick is लाख टके की बेबो. Bebo. And in the gal, in Hindi, gal, these are the gal में रहता था ग्लूकोज. लाख टके की बेबो के गाल में रहता था glucose. Those who can understand Hindi, they can easily engulf it. Others will feel little bit problem. So let me tell you, these gal inside the mouth, glucose powder. लाख टके की बेबो के गाल में रहता था glucose. Now, this means the lactose is made up of what? This is indicating that lactose is made up of beta galactose, beta galactose and beta glucose, and then in between them there is 4 and 1 glycosidic linkage, 1,4 glycosidic linkage. So see kids, I've told you that its mouth is involved and its tail is involved, so its mouth is free, first carbon is free, so it will be what? It must be reducing sugar, and all reducing sugar shows mutarotation. Kids, how was the trick? Do let me know. Trick is good or not? You are able to understand or not? Have you got it a little bit or not, kids? Do let me know. Everyone, trick. बेबो के गाल में ग्लूकोस, बेबो के गाल में ग्लूकोस, लाख टके की बेबो, लाख टके की बेबो, लाख टके की बेबो के गाल में ग्लूकोस. Do let me know in the chat section. Kids, have you got it? Just to let me know, how is this trick? How was the trick, kids? Mind blowing. Jyoti Jain is saying mind blowing. Rest of others, do let me know how was the trick, kids. Rest of others, do let me know how was the trick, kids. Now let's come to the fructose, and now I will let you know what is fructose and how to understand it. Okay, how to understand. Wow, objects, got it, everyone got it, everyone is happy, super proud. Now fructose, now it's a turn for fructose. Fructose, where are you, my dear fructose? Where are you? Hey, my dear Kuti Chetan, fructose, I love you, my fructose. Where are you, my fructose? Where are you? Fructose, 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 मुझे लोग बोलेंगे. Hi fructose, hello fructose. Everyone says I'm being the fructose. Let's see the fructose. Now my dear students, before I start about fructose, let me tell you something about glucose. Otherwise you will get failed. Let me tell you the fructose. Before fructose, let me tell you very important point about glucose. Glucose was open chain structure. We have studied that glucose open chain structure, right? We have seen glucose open chain structure. Now once glucose was going in the closed chain structure, that is hemiacetal ring structure. Now if anyone is asking, hemiacetal ring structure is being pyranose form or furanose form? This hemiacetal ring structure is being pyranose or furanose. Remember that, my dear students. Everyone take a note. This is pyranose form is dominating, major. Dominating means major, but it will form furanose form also. Furanose will be minor. Furanose will be minor, but both will exist. Both will exist. Mark my words, kids. Glucose will exist in both the two forms. Hemiacetal ring structure form, this is a reversible form, and it will be in pyranose as well as furanose. Pyranose is 6-membered ring. In this 6-membered, 5 carbons plus 1 oxygen, and this furanose is 5-membered, 4 carbon plus 1 oxygen. Is it clear, kids? But both will exist, one minor, one major. Is it clear to all of you kids? Just to let me know, is it clear? Point to be noted, my lord. This is a note, very, very important note. It's simple, but it can't be ignored. You have to remember it. Just like this, I would like to tell you kids, fructose. If I tell you fructose in the, this is open chain. Now if I talk about its hemiketal ring structure form. Now if anyone is asking about which form will be exist, now this time kids, furanose form is dominating. Very, very important point. Very, very important point. Let me tell you, very, very important. Furanose, that is 5-membered, and 5-membered means 4 carbons plus 1 oxygen will be major. This will be major. It's a magic, shocking news. Now this time 5-membered ring will become major, and it happens because of functional groups. This is very, very important thing. And pyranose will be the minor one. Pyranose, that means 6-membered ring will be minor. See kids, 6-membered but minor. This is made up of 5 carbons plus 1 oxygen, but still minor. Now kids, it will also exist in both the two forms, but furanose will be major. Remember this. This is very, very important point. This will be major. Many times they have asked. Till now, is it clear? Then I will tell you the structure of fructose. Do let me know in the chat section. Kids, do let me know in the chat section. This is very, very important, kids. Very, very important. Show me the green hearts if you have kept it in your hippocampus. If you have kept this thing in your hippocampus, then show me the green hearts, kids. Very good, kids. Very good, very good, very good, very good. Now the structure of fructose, everyone. This is very, very important. Let's see. See kids, how to draw it, how to write down it. Hey my dear fructose, you are CH2OH. This is your ketonic group, and the third carbon was mother, always on the left hand side. Remember mother. CHOH, total 1 2 3 4 Anche. CH2OH. Now how will you write this fructose? Now see kids, if I say this last and second last carbon OH are on same side, so this is capital D, so I will write D, but in nature, experimentally it is found laboratory. Experimentally, that's why fructose, another name is Lavulose. Remember that, everyone say Lose. Everyone say labulose, 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 labulose. Now, levorotatory. So, in nature, it is found out levorotatory. Experimentally, it is found out levorotatory. You can write a small n or you can write negative sign. So, D fructose. Why I have written this D? Because last and second last they are on same side. So for this I have written D, negative, levorotatory and fructose. Now, this fructose is having 3 chiral carbon atoms in the open chain. So in open chain structure, there are 3 chiral carbons. So total number of optically active isomers 2 raised to power 3, that is 8 answer, right? 8 answer. Now, how to write down its cyclic structure, and then after cyclic structure, Haworth representation, and then sucrose, and then why sucrose is non-reducing sugar. Then carbohydrate will get completed. I will take after that 15 minutes for that amino acids, 15 to 20 minutes, and 10 minutes for vitamins. Then 10 minutes for DNA, RNA. So you are most famous personality because you know bio, right? So not too much time I am going to take, right? I will take only few minutes. Now see kids, this is your fructose. This is very, very important kids. What I am going to tell you, please focus over here. This is going to be the most important thing. See, one, two, three, four, 5. This oxygen is the culprit, negative, positive. It will attack on that ketonic group. Same 5th carbon oxygen. 1, 2, 3, 4, 5. This oxygen will attack from both the side. It will attack from right hand side. It will attack from left hand side. 50-50 Britannia, 50-50, same extent, okay, with the same extent kids. 50% attack from this side, 50% attack from this side. Let's see what you're going to get. So this side attack over here, COH, CH2OH will come to this side. Who has attacked? 5th, 1, 2, 3, 4, 5th carbon O like this, and 6th carbon O like this. You have to make memory map in your brain, right? Mind map. Now here also attack from that side. So CH2OH. Now this will go on this side, OH. 1, 2, 3, 4, 5. 5th oxygen has attacked like this. First see the carbon skeleton, then I will complete it. Just see the difference. Let me draw the mother. Mother is on 3rd carbon. Now compare it with mother. This OH and this OH on different side. 1, 2. Now see kids, these two OH are on same side, and once their first and third glucose mouth was first, so I have compared first with 3. Fructose mouth is second carbon, so I will compare second and third. If second and third OH are on same side, what I have told you, if second and third OH are on same side, what I will say, beta is on same side of mother, so I will say beta D fructose. And see how many membered ring, 1 carbon, 2 carbon, 3, 4 and 5th oxygen, so it is hemiketal furanose ring structure. What I will say, hemiketal furanose ring structure, hemiketal furanose ring structure. And my dear students, there we have got N is equal to 3 chiral carbons we have got, but here how many chiral carbons are there? See, in this structure we are having how many chiral carbons? This is chiral, 1, 2, and let me complete it, HOH, 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 H. Now how many chiral carbons are there? Just see, 1, 2, 3, 4, and 1, 2, 3, 4. Now N is equal to 4. 4 means total number of actively active isomers, 2 raised to the 4, 2 to the 4 to the 8, 16. And in glucose the anomeric carbon was first, but in fructose the anomeric carbon, the carbon which is involved in ring formation, is the second carbon. So this will be your what? This will be your anomeric carbon. Second carbon is anomeric carbon. And these two are anomers of each other. And beta D fructose, hemiketal furanose ring structure, and this is alpha D fructose. Both are being hemiketal ring structures. Till now it's clear. Then I will tell you the Haworth representation. First of all, do let me know kids, till now is it clear? Everyone just do let me know. Wow, objects. Now kids, do let me know till now it's clear or not. Everyone just do let me know kids. Show me the green hearts if it is clear, each and everything is being clear kids. And those who are new, hit the like button kids. Moidin Sullivan, last part is not clear. Which one? Moidin Shalivan, Sahana, very good, dedicated, most dedicated student. Which part? Wow, Deepak Kumar, Moidan Shalivanan. Which part is not clear? Do let me know fast. Moidan. Okay kids, beta fructose. Okay, I will tell you. Try to run. Okay, let me tell you beta D fructose. See, if these two OH, second carbon and third carbon OH are on same side beta and they are opposite, then it is alpha. Second carbon and third carbon. In glucose we have seen first carbon and third carbon. First we have compared with the third one in glucose, but here second we will compare with the third one. So if they are same side, we will say beta, otherwise alpha, right? Now let me draw the Haworth's representation. That holds a hell lot of weightage. Now kids, see, I am going to draw the structure of Haworth representation. Are you ready for Haworth representation? So let me first draw the normal structure, then you can understand the Haworth representation. So if I draw alpha D fructose, right? If I draw alpha D fructose, first see alpha D fructose was like this, OH over here, CH2 on this side, because it's tough, so try to pay attention. 1 2 1 2 3 4 5 6. Now there was bond in between second and 5. It was like this, HOH, HOH. This structure you have to keep it in your brain. I have told you how to draw it. Now see, the second carbon and third carbon OH, they are on opposite side, right? Now first what I will do, I will draw one boat. Get, see, I will draw one boat. Is it clear? I tried to draw one boat. Boat I have drawn. Can you see boat? Everyone, just to let me know, have you seen the boat? I have tried to draw the boat. This is boat. Now can you see, again I have drawn the same boat so that you can understand. Now on this boat I will add the oxygen's tank, not tank, tent, oxygen's tent. Now this oxygen is joining which carbon? 2, 3, 4, 5. This oxygen is having friendship with which carbon? Second and fifth. Oxygen is the friend of second and fifth. It is forming a bridge between second and fifth. Now which carbon should I take second and which carbon should I take as fifth? That is $1 million question. Now see, the one which is attached with CH2OH is fifth, and this is also attached with CH2OH is second. Both are having CH2OH. See kids, both are having CH2OH. Fifth is also attached with CH2OH and second is also attached with CH2OH, but second is attached with OH and this is attached with oxygen also. Both are attached with oxygen. This is common in between second and fifth. This is also common. Only the difference is of H. Here is H and there is OH. Can you see the difference, kids? Only this is the difference. Are you getting my point? Both are having CH2OH as common. CH2OH is common, oxygen is common, this is common, this is common. Just try to understand, kids. This is common. He is also having this part. He is also having this part. So this becomes common. This is common. Only the difference is of this. This is making difference. This and this, they are making difference, kids. Are you getting my point? So now, before drawing anything, first I will draw mother. Mother, why mother, kids? Mother is always at the top. Mother will lie always at the top. Mother will always lie at the top. So second carbon, third carbon, fourth carbon, fifth carbon. First I will draw mother. Mother will always occupy which position, kids? Do let me know. I have told you. Mother will always lie at the top. This is mother. If this is mother, rest of others. If this is mother, then rest of others will be opposite. Will be opposite means OH opposite, OH opposite, OH opposite. Oh, here this fifth carbon is not having OH, it will have only H. This is the difference. Now let me add CH2OH. Let me add CH2OH. Now I am successfully, I have drawn this Haworth representation, and the one who knows how to draw Haworth representation, that candidate is the winner. Let's do, let me know. This I have drawn for alpha D fructose. If you are able to understand this one, then you can do anything. If you are able to understand, do let me know in the chat section. I've tried my level best to teach you this one. Kids, do let me know that you got it or not. I've tried my level best to tell you this thing, kids. Just do let me know. If you're not got it, if you are unable to understand it, I will tell you 100 times. I will tell you 100 times, kids, if you're not able to understand it. But do let me know, kids. And I want to see the chats running fast. Whatever the number of hearts, fire, any symbol you can show, if you're really liking it, I want to see many hearts. The chat should running fast. Many hearts, the chat should running fast. Mother on one side, other on other side. I want to see the chat running very fast. Many hearts, if you really got it. Let me check it out. What's the speed, kids? Let me see, let me know, let me know, let me know, let me know. Wow, Sahana is on the first position. Then let me see others. Only Sahana is at the first position, kids. Okay, now see, kids. Now let me draw. Now how will you draw beta D fructose, kids? Do let me know how will you draw beta D fructose. What you will do. Let me see how many of you can draw Haworth representation for beta D fructose. Now see, kids. Oh, great. Wow, it's running fast. Great, kids. Thank you, kids. Thank you. Really, you made my day. Thank you. Thanks a lot. Now see, kids. Now see. How will you draw beta D fructose? See. How will you draw beta D fructose? See. Try to make what? Boat. Then what you will add? Oxygen. Add oxygen stand. Now draw lines like this. One, 2, 3, 4. Now number it. Second, third, fourth, fifth. Now mother is always at the top. Now 2 and 3 OH will lie on the same side. So second, and this will flip. Just flip. Just see. Flip it. This will go up and this will go down. Flip it. On flipping, this will come down. This will remain over here only, and others at the bottom. This is your beta D fructose. Kids, got it or not? You are able to understand or not? First of all, do let me know. Then I am going to tell you sugar, inversion of sugar. Then carbohydrate will get completed with that. Let me see, kids. They are able to understand or not? Kids, do let me know. Everyone got it. Kids, do let me know. Everyone got it. Very good, very good, very good. Now see kids, now see. Fructose, an inversion of cane sugar. Fructose we know. Now I will tell you sucrose. Let me tell you sucrose. An inversion of cane sugar. Once you know fructose, now you can understand sucrose. Just see kids. Sucrose, and then I will let you know cane sugar. Just a second kids, just a second. See, sucrose kids. Sucrose and inversion of cane sugar. Sucrose is cane sugar. It is also known as table sugar. C12 H22 O11, and my dear students, it is the disaccharide. Once disaccharide was trehalose, that was non-reducing. This is the disaccharide, non-reducing. Non-reducing means it will not show tolerance test, mutarotation, nothing it will show. Will not show mutarotation, tolerance test, Phalanx test, Benedict's test. It will not show all these things. But what's the reason? Everyone definitely wants to know what's the reason behind it. So the reason is, kids, let me show you the reason for this. Sucrose, the disaccharide made up of glucose. If I do the hydrolysis of sucrose in presence of enzyme sucrase, that sucrase is also known as invertase. If I do the hydrolysis, what I will get? Alpha D glucose plus beta D fructose. I will get beta D fructose. I will take 10 minutes more, kids, not more than that. It will get completed within 10 minutes, right kids? So don't worry, it will get completed within next 10 minutes, right? So first of all, let me tell you how the inversion of cane sugar. This sucrose in the market is available as dextrose in the market. In the solid form it is dextrose. Solid form it is being dextrose. When you put it inside the water, it will give 1 mole of glucose, 1 mole of fructose. We know very well that they are inside the water. This is being dextrorotatory. And this is being laborotatory. Laborotatory. Now, my dear students, 1 mole of this, 1 mole of that. Its optical rotation is less and its optical rotation is more. Less optical rotation, more optical rotation. So the more one will neutralize less, this will get finished, only this will left. This is known as enantiomeric axis. This is known as what? Enantiomeric axis. So this will control the solution's optical rotation, because this is levorotatory, so the overall solution will become levo. Now from dextro it got converted to levo. Now the sucrose was dextrorotatory, now the solution become levorotatory. Now this is known as what? Inversion of cane sugar. You got it? The dextrorotatory solution got converted to levorotative. One answer you got. Now the second answer, that why this will not show mutarotation. What's the reason, right? Let me tell you that reason, kids. Kids, you know that glucose was like this, CH, alpha D glucose was like this, CH, second carbon, third carbon, fourth carbon, fifth carbon and sixth carbon, and this was bonded like this through oxygen, and CH, OH, CH, OH and CH, OH and CH. Its mouth was first carbon, it was getting open closed, this was the mouth, or you can say mouth was the anomeric carbon, this was the anomeric carbon. Now fructose, beta D fructose was CH, OH, CH2OH, third carbon, CHOH, fourth CHOH, fifth CHO, like it, 1, 2, 3, 4. This H is not there, okay, and CH2OH. Now the second carbon was anomeric carbon. This is the mouth, this is the anomeric carbon, right? Now what will happen? The water will get eliminated out from its first carbon and its second carbon. Water will eliminate out like this. Now both the anomeric carbon are involved in bond cleavage, both the mouth are involved in bond formation, glycosidic, so no mouth is free, so they will not be attacked by anyone. So 1, 2, glycosidic linkage, no free carbonyl, so non-reducing sugar. You got it, kids? Non-reducing sugar. Everyone got it? The reason, if you liked it, show me the green hearts. Carbohydrate got completed. Now let me tell you in 5 minutes the amino acids, and then 2-3 minutes vitamins, so it will get completed. Will take only 5 to 6 minutes. Are you ready, kids? Is everyone ready? Kids? Do let me know. Now see, amino acids. Amino acids, we know that essential amino acids and the most basic amino acids which are Most basic amino acids. If I say about amino acids, all amino acids are optically active except all amino acids are optically active except glycine. Am I right, kids? Except glycine. And they are further divided into essential and non-essential amino acids. Am I right? Now, the most important is essential one. Essential amino acids, let me tell you kids, essential one. Essential amino acids. Before I tell you essential amino acids, let me tell you the formula is NH2 CHR COOH. They are having both type of functional group, that is basic as well as acidic. Basic as well as acidic. So generally they will form deuterion. What they will form? Deuterion. You know very well about deuterion, but let me tell you first about essential amino acids. Essential. If I ask you which is most basic amino acid, you won't be able to understand, you won't be able to give the answer. So remember that arginine is most basic. Arginine. Lysine. You know, now world, today's day, that Arjit is the most, what to say, most famous one, or the first number singer. Arjit, lassi pilo haste haste, hastidine, histidine. Now they are essential amino acids as well as I am writing their basic strength also, kids. This is the basic strength. This is the order. These three are basic amino acid and this is most basic. Remember that. Very, very important question. Why this is most basic? The reason is it is having guanidine. Its R is guanidine. Remember that. Its R part is being guanidine. You remember guanidine? Its nitrogen is having localized lone pair. Localized lone pair. And its nitrogen is having delocalized lone pair, extra nitrogen. Delocalized lone pair. These are the reasons. If you see their structures, you will get it what I have written. Now, Valentine, you can say celebrate Valentine from 3 o'clock to 9 o'clock. 3 o'clock to 3:09. 3 o'clock to 9 o'clock. 3:09. Then trimethy and phenny. Tri means tryptophan. Methy means methylalanine. Phenny means phenylalanine. Leuci and isoleuci. Leuci and isoleuci. These are essential amino acids. Gets clear? Amino acids clear or not? Now only vitamins, but let me tell you deuterion, okay? First I will tell you deuterion, then amino acids. Kids, do let me know. You got it? Till now it's clear? Till now is it clear, kids? Do let me know. (20 to 22), yes. 20 to 22 amino acids. Out of these, how many I have written? 5 I have written. 5 I have written, kids. Now, Let me tell you, kids, deuterion. What is deuterion? You must be thinking about deuterion. What do you understand by deuterion? Now, my dear students, if I say that I am having an amino acid NH2 CHR COOH, and if I place it in a strongly acidic medium like HCl, now this HCl will donate, this is stronger acid, so stronger acid will donate H plus. This H plus will go and attack on this ammonia's lone pair, so it will look like NH3 positive CHR COOH, and this will become cation. And during electrolysis, it will move towards cathode, So it's not deuterion, it will move towards cathode. Now, if I say the same amino acid, there are three cases, case number 1, case number 2, and case number C. I will tell you the same amino acid if I place it in strongly basic medium, now this base will attract this proton and it will look like this. Anion, and during electrolysis it will move towards anode. Now, my dear students, there we have made very strongly medium, here we made very basic medium. Now, I can say here the pH is like 1 or 2, here the pH is like 13 or 14, but if we shift a pH according to suitable condition, that like only this will leave its proton, no one else can leave proton. This proton should go and attack over here. So a specific pH that is different for different amino acid, but generally this pH is generally 6.4. For acidic amino acid it will be different, for basic amino acid it will be different, but generally it is 6.4. At this pH it will exist like this, means it will look like this: NH3 positive CHR COO negative. Now it is having a negative charge as well as positive charge. It will act as anion as well act as cation. It is cation, cationic part. This is being anionic part. So it is dipolar. And when you supply electric current during electrolysis, it will not be able to decide to which side should it go. It will try to move towards anode. Now cathode will approach, attract. If it is going towards cathode, then anode will attract. So it won't be able to move neither towards cathode or towards anode. So this pH is known as isoelectric point, and this is behaving as deuterion. This is your deuterion or dipolar or ampholyte, whatever you want to say you can say, and this pH is known as isoelectric isoelectric point. So this is all about amino acid. Now I will take 2 minutes for vitamins, 2 to 3 minutes, just 2 to 3 minutes, kids. Just to let me know everyone got it, everyone is able to understand till now, kids. Do let me know you got it, everyone got it, kids. Do let me know. How is Baba's biochemistry, biomolecules, kids? How is Baba's biomolecules? You have to tell me in the comments, not right now because I don't have time. You have to tell me once the video is over. You have to tell me in the comments, okay? Now let me tell you vitamins. Vitamins. Only one thing is left. Vitamins. Just see vitamins. Now, there are two types of vitamins, water soluble and fat soluble, right? Water soluble, fat soluble. Now my dear students, nowadays you must have heard that people are having headache, but in my village they never complain about headache. They are eating so much fat that they are always complaining about fatigue. They never have headache. They always have what? Tell me, they always have what? Fatigue. Fatigue. They never complain about headache. They always complain about fatigue. Now, what do you mean by fatigue? F for fat soluble. I would like to say F for, this is the trick. F for fat soluble. Fat soluble vitamins are A, D, E, K. So what is left? Water soluble are B complex except B12 and vitamin C. Now my dear students, what are their chemical names? You have to remember. Vitamin A is retinol, and if you're not taking retinol, the deficiency disease will be nyctalopia. Nyctalopia, that is known as night blindness. Night blindness. Vitamin D is known as calciferol. Chemical name is calciferol. And if you are not taking vitamin D, in kids it is rickets, and in old people, elder one, it's osteomalacia. So rickets in kids, elder person, it is osteomalacia. Vitamin A is tocopherol. Its name is tocopherol. And vitamin K is phylloquinone. Phylloquinone. Now vitamin C is ascorbic acid, and its deficiency disease is scurvy. Very, very important, scurvy. They will generally ask scurvy. And B complex, B1, B2, B6, B12. B1 is thiamine, riboflavin, cyanocobalamin, B6 I don't know, and beriberi is the deficiency disease. Beriberi. Completed, kids. Over and out, it's completed. Done and dusted. Whole biomolecules I taught you, kids. Okay? Once this video is over, you have to tell me how much you liked it, how much you are satisfied. You can check your NCERT also, each and everything I have told you, kids, right? Wow, Medico, fantastic, fantastic. Kids, Shubhratri, Shabak Khair, Sayurana, Dhanyavad Alu. Good night to all of you kids. Okay, I will share PDF. Okay, Baba will share the PDF, kids. Bye to all of you kids. Bye bye. God bless you. Love you kids. Bye to each and everyone. Shubhratri, Shabak Khair. Thank you, Moideen Sullivan, for thinking this much for Baba. Jyoti Jan, thank you. Medico, Ritas, Sahana, Dararfot, everyone. Bye, kids. Bye. Bye to all of you. Heisenberg, thank you. Dream, TMC, thank you.